Mathematics Class 8 Chapter 21 Surface Area, Volume and Capacity of Cuboid, Cube and Cylinder by Zainab Bahori.
Dear students, let us begin the last chapter of our mathematics syllabus, that is surface area, volume and capacity. In the last semester, we have learnt about some solid objects like cube, cuboid, cylinder, etc. Let me revise some definitions related to solids. Volume: the space occupied by a body, here means solid, is called as a volume. Capacity of a container is nothing but the internal volume. It means if suppose any solid you will feel some matter, then the amount of matter which can be filled in that solid container is called as capacity of that container, and it is nothing but the volume of that particular solid. Here we are going to discuss about volume as well as total surface area of three solids, that are cube, cuboid and cylinder. Cube is a solid with all the sides equal. It has 1, 2, 3, 4, 5, 6, 7, 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges, and 1, 2, 3, 4, 5 and 6 faces. Let us see how to calculate volume as well as total surface area of cube. As I told you before, length, breadth and height of any cube is equal. A cube has 6 faces, 12 edges, 8 vertices. So, volume of cube can be calculated by the formula length into breadth into height. As all these three are equal, volume of cube can be calculated with the side cube. Now let's see how to calculate total surface area of a cube. There are 6 faces of a cube with all sides equal. So if suppose you will consider this one face which is square in shape, so its area is side into side, that is side square. Similarly, total 6 faces will have 6 into side square. So we can write down here total surface area of a cube is equal to 6 into side square. Dear students, next solid is cuboid. You can observe here, this is a cuboid. Length, breadth and height. These are the 3 dimensions of a solid cuboid. The capacity of cuboid, that is the internal volume of cuboid, can be calculated by making the product of length, breadth and height. A cuboid has 3 dimensions, and with this 3 dimension, 1, 2, 3, 4, 5, 6, 7, 8 vertices, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges and 1, 2, 3, 4, 5 and 6 surfaces. Surface area of each face can be calculated as 2 into length into breadth or 2 into breadth into height or 2 into length into height. So altogether, for all the 6 faces of a cuboid, we can calculate total surface area is equal to 2 into sum of all these 3, that is length into breadth plus breadth into height plus height into length. Here we go with the next solid, that is cylinder. A solid cylinder which has a uniform circular cross section. It is made of a curved surface and the 2 circular top as well as bottom surfaces. Total surface area of cylinder can be calculated as curved surface area plus 2 into area of cross section. Area of curved surface is nothing but 2 into pi RH and area of cross section is equal to 2 into pi r square. That is 2 pi r is common in both the terms. So h plus r will remain in the bracket and so total surface area of cylinder is 2 pi r into h plus r, while volume of cylinder is equal to area of cross section into height, that is pi r square into h, pi r square h. So based on this all the formulae and some of the conversion of the units which we have learned in the previous classes, let us go to solve exercises from this lesson.
Let us solve exercise 21A.
Here we are taking question number 1. We have to find out volume and total surface area of cuboid. Let us take the second example from the question 1. The length of cuboid is 3.5 meter, breadth is 2.6 meter and height is 90 centimeter. We have to find out volume of cuboid as well as total surface area of cuboid. Let us observe here height. It is 90 centimeter while the other units are in the meter. We will convert 90 centimeter into the meter by dividing 100 to the 90. So height will become 0.9 meter. Now we will calculate volume of cuboid. Length into breadth into height. On substituting all the values, we get 3.5 into 2.6 into 0.9, that is 8.19 meter cube is the volume of given cuboid. Let us find its a total surface area, that is 2 into length into breadth, 3.5 into 2.6 plus breadth into height, 2.6 into 0.9 plus height into length, 0.9 into 3.5. The product of 3.5 and 2.6 is 9.10 plus 2.34. This is the product of 2.6 and 0.9 plus the product of 0.9 and 3.5 is 3.15, and this sum we will multiply by 2. The next step, sum of this all number is 40.59 multiplied by 2. That is 29.18 meter square is the total surface area of given cuboid. Now we will take the second question. This question is based on the same formula. The difference is we have to convert the formula Since out of the three values, one value is not given. That is, from the length, breadth and height, any one value is asked to calculate. Let's see first example. Volume of given cuboid is 3456 centimeter cube. Its length is 24 centimeter while breadth is 18 centimeter. As we know, volume of cuboid is length into breadth into height. We will substitute all the values. Volume of cuboid is 3456, length is 24 into breadth is 18 multiplied by height. Height we have to calculate. All these terms we will transpose. These are multiplied by. Here they will become divided by. Since height is equal to 3456 upon 24 into 18. 12 2s are 24. 12 288 are 3456. Further, we will divide here by 9. 9 2s are 18 and 9 32s are 288. Here you can make the division according to your choice of calculation and number crunch. Finally, 32 divided by 2 into 2, that is 4. 32 divided by 4 is equal to 8 centimeter cube is the height of given cuboid. Now let us solve question number 3. In this, the length, breadth and height of cuboid are in the ratio 5:3:2 and its volume is given 240 centimeter cube. We have to find out length, breadth, height of the cuboid, also the total surface area of cuboid. Cube root of a is equal to cube root of x, that is 2. Hence, length is equal to 5x, 5 into 2, that is 10 centimeter. Breadth is equal to 3x, equal to 3 into 2, 6 centimeter. While that of height is 2x, 2 into 2, 4 centimeter. From this all value, we can calculate total surface area of cuboid. 2 into length into breadth plus breadth into height plus height into length. On substituting the values, we get 2 into 10 into 6 plus 6 into 4 plus 4 into 10. And on finding out the product as well as sum, we get here finally 2 into 124, that is 248 centimeter square. Let's move with one more example from this exercise. Dear friends, in this question, we have got 4 cubes of length and breadth 9 centimeter. These 4 cubes are placed end to end in the straight line, so that you can observe here a cuboid shape is formed. We have to find out length of cuboid when the cubes are placed close to one another in the series. We have to find out total surface area of this total cuboid formed due to the placing of the cubes. Also, we have to find out volume of this cuboid. Let us solve one by one. Since the length of cube is 9 cm and there are 4 cubes placed end to end, the length of cuboid can be calculated as 9 into 4, that is 36 cm. Breadth as well as height of each is 9 cm. Means this total cuboid has the length as well as breadth same 9 cm only. Just length is 36 cm. From this we can calculate the total surface area of a cuboid by the formula 2 into length into breadth plus breadth into height plus height into length. Substituting the value, we get 2 into 36 into 9 plus 9 into 9 plus 9 into 36. So, 2 into 324 plus 36 plus 324. And the sum of this all is 729. On multiplying by 2, we get here 1458 centimeter square as the total surface area of the cuboid formed here. Let us calculate volume of this cuboid. that is length into breadth into height equal to 36 into 9 into 9, that is 2916 centimeter cube. Solve the rest of examples from this exercise. Let us solve few of the word problems from the next exercise. Dear class, now we will solve exercise 21b, which is based on word problems of cube and cuboid volume as well as total surface area. Here we go with the first question. The dimensions of hall is 40 meter, 25 meter and 15 meter. If each person sitting in hall takes 5 meter cube of volume of air, then we have to find out how many persons are sitting in the hall. For calculating the number of persons, first we have to calculate volume of hall. So volume of hall is equal to length into breadth into height, that is 40 into 25 into 50. The product of these all three numbers is 15,000 meter cube. Now, number of persons sitting in the hall is equal to volume of hall divided by the volume of air consumed by a person. By taking this formula, we will find out the number of persons. Volume of hall divided by volume of air required by each person, that is 15,000 divided by 5 equal to 3,000. So there are 3,000 persons sitting in hall, or a hall can hold 3,000 persons. We have to find out area of metal sheet required for making a tank of the dimensions 30 meter, 24 meters and 4.5 meters. Also we have to find out cost of sheet if the rate of sheet is 65 rupees per meter square. As we have to prepare a tank from the metal sheet, there are two things required for it. First one, walls of the metal sheet and its base. So area of walls of tank can be calculated as there are 4 walls, means 4 sides are there of the tank. So we will find out area of walls of tank, that is 2 into length plus breadth into height equal to 2 into 30 plus 24 into 4.5. By calculating this, we get 2 into 54 multiplied by 4.5. So total, therefore, area of walls of tank is equal to 486 meters square. Now, we have to find out area of the floor of the tank, that is length into breadth. So length is 30 and breadth is 24. 30 into 24 is equal to 720 meters square is the area of the floor of the tank. So, total sheet required is equal to 486 plus 720, that is 1206 meters square. This much sheet we require for making this tank. Now, cost of it we can calculate by multiplying area with cost. That is 1206 multiplied by 65 and it is rupees 78,390. So we have to pay 78,390 rupees for purchasing the iron sheet of 1206 meters square in order to make the given tank. Dear students, remaining examples you solve by yourself. Let us solve few examples from exercise 21D and E. Question 1. Here a cylinder of height 20 cm and diameter of its base is 14 cm is given. We have to find out its volume and total surface area. Let's see how to do. Diameter of cylinder is 14 cm. Since diameter is double of the radius is equal to 14 upon 2, that is 7 centimeter. Volume of cylinder we can calculate with the formula pi r square h. Remember, the value of pi is approximately 22 upon 7 or 3.14. We will use here 22 upon 7. So 22 upon 7 multiplied by 7 multiplied by 7 into 20. Here 7 into 7 because r square. 7 cancel, remains 22 into 7 into 20. 7 into 20 is 140. So the total product is 3080 centimeter cube is the volume of cylinder. Now total surface area we can calculate by the formula 2 pi r into h plus r. 2 into pi is 22 upon 7, radius is 7 and height is 20 plus radius is 7. On substituting the values, now we will calculate. So 7 here gets cancelled, remains 2 into 22 into 27, that is 24 into 27. So value of total surface area of a cylinder is 1188 centimeters square. Dear students, let us solve one more interesting question from this exercise, question number 5. In this question, the ratio between curved surface area and the total surface area is 1:2. We have to find out the ratio between height and radius of the cylinder. So this is very easy question. Let us see the solution. We will consider r is the radius and h is the height of the cylinder. Since the ratio of curved surface area and total surface area is 1/2, we can write down that formula. So 2 pi r h upon 2 pi r into h plus r is equal to 1/2. Here 2 pi r is common in the numerator and denominator, it will get cancelled. Remains h upon h plus r equal to 1/2. On transposing the denominators, we will get 2h is equal to h plus r. Since opening the bracket, we will transpose the like terms together. So 2h minus h is equal to r and 2h minus h is equal to h, that is h is equal to r. It states that height is equal to r, means they both are in the ratio of 1:1. In other words, we can say radius and height of this cylinder are same. Dear students, solve rest of the questions from these exercises and practice well. Best of luck for the final assessment.